Okay. Good morning, students. So we last class discussed about the topic is what is the difference between CP and CV. So CP minus CV is equal to R. Okay. Already proved that in the last class. CP minus CV is equal to R. Okay. Got it. So now today discuss about the topic is isothermal process and adiabatic process. Isothermal process and adiabatic process. First of all, now we take an isothermal process. In isothermal process, in this process, so the pressure is changes and volume is changes at a constant temperature. So that is isothermal process. Isothermal process. So pressure is changes and volume is changes isothermally at a constant temperature. Okay. So now expression for isothermal process and equation for isothermal process now is taken cylinder. So that is called as a taken cylinder. So 1 mole of the gas is taken. So frictionless piston is taken, and so cylinder is containing 1 mole of the gas. Cylinder is containing 1 mole of the gas. Okay. So now is taken. So the pressure is changes P1 to P2, and so the volume is changes V1 to V2. Okay, isothermally. Okay, at a constant temperature. Isothermally at a temperature T. So the pressure is changes P1 to P2, and volume is changes V1 to V2. Pressure is changes P1 to P2 and volume is changes V1 to V2. That temperature is T. Okay. So the isothermally is converting. Okay. So now we are taken the small extension, that is small change in volume dV. So that is a small work done dW. Okay. So dW is taken. So small amount of the work done. Small amount of the work done due to the extension. Okay, dV. Okay, so the dW is equal to P dV. We can write equation. dW is equal to P dV. What is the isothermal? Isothermal means okay, so the pressure is changes, volume is changes, but at a constant temperature. So that process is called as a isothermal process. So dW is equal to P dV. dW is equal to P dV. So that due to the isothermal process, only due to the small extension, so that is the dV. So small work done, that is the dW is equal to P dV is taken. Okay. So according to equation, PV is equal to RT. 1 mole of the gas. Okay, ideal gas equation is taken, that is the PV is equal to RT. PV is equal to RT. Okay. So P is equal to RT by V is taken, and so substituting in the equation dW is equal to P is equal to RT by V. So RT by V into dV. RT by V into dV. Okay. So now is taken extension will be produced, or extension is taken from V1 to V2. So the total work done is taken. So the total work done, so that is the W. So W is equal, so integration is taken. So integration of dx is equal to x. Okay. So this is called as a new word. Okay, so this term is called as a integration. Okay, so integrate. So under of dx is equal to x. So integration of dw is equal is taken W. So this is called as a small work done. So the small work done, integration is taken, total work done will get. Okay. Now here also like that, I will, okay, so to get off total work done, so total extension, that means so the V1 to V2 taken, V1 to V2, okay, that means so the integrating on both sides, so dW, the limitations is taken V1 to V2. So dW already find out that value is V1 to V2. So dW is equal to RT by V dV. RT by V dV. So the integration dW we get total work done W. Okay. So the total extension V1 to V2. Okay. So integration V1 to V2 RT by V dV. RT is constant. Okay. So the constant term is taken outside. So remaining equation we can write V1 to V2 1 by V dV. Okay. 1 by V dV. So integration 1 by V dV is equal to log V. 1 by V dV is equal log V. So for example, general equation, so 1 by x dx is equal to log x. Okay, integration of 1 by x dx is equal log x. So the formula will be applied to the equation. So we get the 1 by V dV is equal to log V. Okay, so here taken total work done, W is equal, RT is constant. RT is constant. So remaining equation, integration of 1 by V dV is equal to log V. Okay, so log V. After integration, so the limits go to outside. So that we can write V1 to V2. V1, V2. After integration, limits are go to outside. Okay. So is taken RT log V. So one limit is applicable, upper limit. So we place substituting V2 minus V plus substituting V1. Okay, that means upper limit substituting minus lower limit substituting. Okay, so log V2 minus log V1. Okay, so RT log V. So V plus substituting V2 minus. So V plus substituting V1. So minus V1 log V1. Okay, so according to equation, so log A minus log B, that is the log A by B. Okay, log A by B. Now here we can write the equation RT log V2 minus V1. So V2 by V1. Okay, V2 by V1. Okay, so that is equal RT log V2 by V1. So here taken substituting E. Okay. V is taken in another words, that is the converting log base 10. Log base 10. Here log base E. Okay. Log base E is converting log 10. Log base E is converting log 10. So that equation we can write R, that is a 2.303 RT log base 10 into V2 by V1. V2 by V1. Okay. So 2.303 RT log base 10 V2 by V1. This is called as a total work done isothermally process. Okay, isothermally process the total work done. The gas. So W is equal to 2.303 RT log base 10 V2 by V1. Okay, so this equation is converting in another form is also. Okay. So according to ideal gas equation, PV is equal to RT, okay, or P1 V1 is equal to P2 V2, okay. So P1 by P2 is equal to V2 by V1, okay. So V2 by V1, okay, according to Boyle's law. According to Boyle's law, so P1 V1 is equal to P2 V2 is equal to constant. Okay, got it? According to Boyle's law, so PV is equal to constant. Now is taken 2. So P1 V1 is equal to P2 V2 is equal to constant. That meaning, so P1 by P2 is equal to V2 by V1 is equal to constant. Now we have taken V2 by V1. So V2 by V1, that value, so P1 by P2 is also substituting. Okay, so that is worked on. W is equal to 2.303 log base 10 RT. Okay, or RT, so log base 10. So V2 by V1. Okay, so V2 by V1 substituting P1 by P2. Okay, P1 by P2. Okay, got it? Okay. Okay, right. So now here taken, so in isothermal process, so we get converting to the, so V2 by V1, V2 by V1, so in another form, so the P, that is by using the ideal gas or Boyle's law, so the P1 V1 is equal to P2 V2, that is equal to constant. So P1 by V1 is P1 by P2 is equal V2 by V1. So V2 by V1, so place substituting that equation, so we get the total work done 2.303 RT log base 10 P1 by P2. Okay, right. So now discuss the another topic, so that is the adiabatic process. Okay, adiabatic process. So right, in adiabatic process, okay, adiabatic process. So adiabatic process, so in this process, so the pressure is changes, so volume changes and the temperature is changes. Okay, that is one, so isothermally is taken isothermally. So that means, so here taken, so the pressure and volume and temperature is also changes isothermally. Okay, so that is called as a adiabatic process. So what meaning of the adiabatic process? Okay, so the pressure, volume, temperature is also changes. Okay, takes place, so isothermally, so that is called as a adiabatic process. That means, so Ushnam is constant, Ushna prasaram is constant. Okay, isothermally is constant. So now we have taken, so cylinder. So cylinder is taken 1 mole of the gas, so frictionless piston. Okay, frictionless piston. Okay, so the gas is taken, pressure P1 and volume V1, temperature is T1. Okay, is converting, so the pressure P2 and volume T2, temperature is T2. Okay, so now we have taken 1 mole of the gas in adiabatical process. So the pressure P1 is converting the P2, or so the initially the pressure P1 and volume V1 and temperature is T1. Okay, so the pressure is T2. That is the volume is V2 and temperature is T2 finally. Okay, so in adiabatic process, during the small expansion, that is the dV. Okay, the work done is the dW. So small work done is dW. Okay, small work done is taken dW. So dW is equal to P dV. Okay, dW is equal to P dV. Small extension or small change in a volume, the work done is taken dW. Okay, so we can write that equation dW is equal to PdV. dW is equal to PdV. Okay, so dW is equal to PdV. So but in adiabatic process, okay, in adiabatic process, so PV is or to the power of gamma. PV to the power of gamma is equal to take a constant. Okay, PV to the power of gamma is equal to constant or is taken, that is the K. Okay, so here taken P, so P is equal to K by V to the power of gamma. Okay, now substituting in the equation, so dW is equal, okay, so dW is equal to K by V to the power of gamma dV. K by V to the power of gamma dV. So now here taken total extension V1 to V2. Okay, that is will get the total work done. So that is the W. So the total work done W already similar pattern here also like that. So the integration on both sides. So the limits are taken V1 to V2. Limits are taken V1 to V2. Okay, so V1 to V2 is taken dW. So integration of dW. So integration of dW is equal, we get W. So that is means general equation we can write so integration of dW is equal to W. Integration of dx is equal to x. Integration of dy is equal to y. Integration of ds is equal to s. Okay, here also like that. Integration of dw is equal to, we'll get w. Okay, so already dw we know that. So k by v to the power of v1 to v2 k by v to the power of gamma dv. Integration of v1 to v2 k by v to the power of gamma dv. Okay, so k is the constant. So constant term is taken outside. So okay, so integration of v1 to v2. Okay, so k v to the power of minus gamma. Okay, v to the power of minus gamma dv. So v to the power of gamma is go to v to the power of, we can write the v to the power of minus gamma dv. Okay, so it is a denominator word. So v to the power of minus gamma dv. Okay, so the k is the constant term. K is the constant term. So v to the power of minus gamma dv. So integration of, okay, integration is taken. So that is w is equal. W is equal. Integration is taken. So k is the constant. V to the power of minus gamma plus 1 by minus gamma plus 1. Okay, limits are taken. Okay, so limits are taken v1 to v2. So general equation x to the power of n dx is equal x to the power of n plus 1 by n plus 1. Okay, x to the power of n plus 1. And the integration of x to the power of n dx is equal x to the power of n plus 1 by n plus 1. That means, so power to add 1 by, we can write the denominator. Okay, so now here also like that, x to the power v to the power of minus gamma. V to the power of minus gamma plus 1 by minus gamma plus 1, here we can write. Okay, got it. So now we are now in taken upper limit and minus lower limit are substituting in this equation. So k v2, okay, minus, so v2 minus gamma plus 1. Okay, v2 minus gamma plus 1, k by minus gamma plus 1. So v2 minus gamma plus 1, so minus v1 minus gamma plus 1. Okay, minus gamma plus 1. So v2, v plus substituting upper limit, so v2 minus gamma plus 1 minus lower limit are substituting v1 minus gamma plus 1. So k and minus gamma plus 1 is right inside. Okay, we can write outside. So remaining equation we can write. So the w is equal to, so 1 by minus gamma plus 1. So k v2 minus gamma plus 1, k v1 minus gamma plus 1. Okay, so we can write that equation already we know that, so Pv to the power of gamma is equal to constant. So P1 V1 gamma is equal to P2 V2 gamma is equal to, so some constant is taken K. Now we have taken K, V2 term. So V2 term means substituting P2 V2 to the power of gamma. Okay, so 1 by minus gamma plus 1, minus gamma plus 1. K value is taken, P2 V2 to the power of gamma. So P2 V2 power of gamma, and so V2 minus gamma plus 1. Okay, got it. Minus. So K value is substituting P1 V1 to the power of gamma, and so V1 minus gamma plus 1. Okay, got it. So now we have taken 1 by minus gamma plus 1. Okay, so we have taken V to the power of minus gamma plus 1, V to the power of minus gamma, and V2. So P2 V2 power of gamma, and V2 minus gamma, and V2. Okay, minus P1 V1 gamma, V1 minus gamma, and V1. Okay, so V to the power of A plus B, V to the power of A and V to the power of B. Okay, so here taken, so these are to cancel, so we can write the equation 1 by 1 minus gamma, so P2 V2 minus P1 V1. Okay, so 1 by 1 minus gamma, P2 V2 minus P1 V1. Okay, got it. So now we continue after next class. Okay, thank you students.